In the future, power will be generated primarily through renewable energy sources such as wind and solar. Smart grids with storage and flexible capacity will redefine how we produce and consume energy. AI will support us in every aspect of our daily lives, facilitating this transformation from traditional to digital infrastructure. This is not science fiction. It is a necessity to decarbonize the energy supply and fight climate change. The state-of-the-art for most data-driven tasks still sits deep in statistics and basic mathematical correlation. In the last decade, however, with the emergence of applied AI, we have seen a step change in data accessibility and global knowledge transfer. AI is redefining how we view industry, health, manufacturing, and power. Cognitive is using AI to tackle the deep data problems in offshore wind, to provide the steps for AI-powered automation and optimization of power generation. At a time where the race to decarbonize has never been more important, Cognitive is supporting offshore wind to perform as we know it must. In fact, modeling suggests that Cognitive's technology could lower the levelized cost of energy by up to 2.7%.
Today I'm going to be speaking about Wind AI, Cognitive's Innovate UK project with RWE and the Offshore Renewable Energy Catapult. And together we're looking to see and quantify what is the hidden losses that are occurring across wind farms.
The Offshore Renewable Energy Catapult, the UK's leading technology innovation and research centre for offshore renewables, is supporting innovative businesses in developing and commercialising the next generation of digital tools to support the industry.
The requirement for deeper insights using our specialist O&M systems, along with tens of thousands of measuring points, create a complex opportunity and forms a requirement for a highly sophisticated solution. One of the most technically challenging areas to deploy AI and advanced analytics is in support of our highly skilled engineering teams. We are integrating advanced analytics and AI across our enterprise.
There are tens of thousands of signals across a wind farm, which are currently stored in a historian, so we can access them, we can use that data. So flipping the problem on its head a little bit, we're using machine learning and artificial intelligence. We're looking at that data and looking at the deeper relationships that exist within it and between all the turbines across the park. We're at a critical point of where we are with the environment. The climate crisis is spiraling out of control. As a result, we're relying on wind and other renewable energy assets to help decarbonise the grid. At Cognitive, we've been leading the charge on predictive maintenance for well over a decade now. The founders have come from areas where we've been helping engineers realise what their assets can actually do, improving the reliability of those assets, making it safer for people to work in those very dangerous environments. We're doing that with wind. We're using advanced machine learning methods to go beyond what a human can do. We're going beyond human level analytics to find optimal strategies, to find predictive maintenance and predictive possibilities which otherwise go undetected. This is making renewable assets more effective, more efficient, more reliable, safer to work with, and we need all of these things to combat the climate crisis. Currently, the method of conducting performance monitoring on wind turbines is normally via power curve monitoring. And what that means is we look at the wind measurement that's recorded by the anemometer, and then we relay that to the power output of that turbine. The anemometer is notoriously inaccurate, and this means that we are sometimes unable to detect degradation on a turbine until it's at 10, 12 or 15% of its potential is lost before we can see it. That's the problem that scales across the whole industry. So the anemometer isn't the only way that we can measure the wind speed. We can use LiDAR instead. And this is the state-of-the-art technology, but it's also extremely expensive to the point where it's prohibitive to retrofit that across a whole fleet. We can use LiDAR-based studies to look at performance assessment, but it doesn't cover the everyday operations of a wind farm.
In order for it to gain traction in the industry, Cognitive Business needs to demonstrate clearly how Wind AI will quantify performance issues in wind turbines more accurately and faster than is currently possible with MetMast and LiDAR studies.
In order for our teams to utilize next-generation solutions, we require rigorous testing and analysis of any solution we deploy for our assets. Catapult are providing validation within this project through the use of a newly installed precision LiDAR system.
Our Catapult is supporting cognitive business, improving wind AI's effectiveness. We are undertaking a detailed power performance assessment at one of RWE's wind farms using traditional methods.
The early results that we're seeing in collaboration and working with RWE and their engineers is that we're starting to see that we can detect changes as low as 1% of the turbine. In fact, we've even seen that we can detect up to 0.1% changes with high accuracy, which is well beyond even what LiDAR is able to do, which is somewhere in the 2 to 5% range.
In operational business terms, our goal is to reduce breakdowns, increase availability and performance safely, while supporting optimization of our O&M process. Working with Cognitive, we aim to identify measurable improvements through the use of wind AI for a safer and greener future.
Digital technologies and AI are a cornerstone of the UK's industrial strategy alongside clean growth and offshore wind. Not only will the development of wind AI lead to performance enhancements in the UK's rapidly expanding offshore wind fleet, but it will be readily exportable, leading to further economic benefit at home in the UK.
The problem that wind AI is tackling and looks to be solving is worth $4 billion a year in increased revenue, which is just profit for the companies that are owners of these assets. That's just forgetting about the massive improvement to safety and the environmental benefit we do by offsetting that generation. 6 to 7 million cars can be taken off the road a year from the CO2 offset of that capacity without back in. Estimations are showing it could reduce the levelized cost of energy by 2.7%, which is a huge deal. That's crazy.